Okay, so in this video, I'm going to talk about factoring trinomial squares, and then later I'll discuss factoring difference of squares. First, trinomial squares are pretty much in this form. I don't expect you to memorize this. I just want to show you what it looks like when I factor this out and how to write the ending result properly. So looking at this, we'll just factor like normal. There's no number in front of the x squared, so I can go straight into saying, okay, x blank and then x blank, whatever. And I find two numbers that add up to 6 and two numbers that multiply to 9, which is just 3 and 3. So x plus 3, x plus 3. Now if you notice, because they're the same, it's much nicer if you just write it as x plus 3 squared. So that's really why I just wanted to talk about this is if you get this kind of result, just write it as x plus 3 squared or whatever squared. Just makes it a lot nicer to look at. Yeah, so these aren't too bad. You just kind of, I guess it's important to get in that habit of writing as squared. So I think I'll just write, maybe do two, maybe two more examples of this and then probably move forward just because it's a very straightforward concept. Here, I'm going to rearrange and make it x squared minus 4x plus 49. Figure out two numbers that add up to negative 4 and then multiply to 49. Okay. Oh, okay, 14. It was 14. I don't know why I missed that. I was curious why. I was like, I don't know any numbers there that will like add up to 4. Anyways, 14. In this case, we can use negative 7, like that. So we'll have x minus 7 and x minus 7, which you can just simplify to x minus 7 squared. All right. And then we'll just do one more. Right, let's do, okay, this one's a little bit more challenging. Oh, okay, actually, I don't like how this one turned out, but oh well. So kind of just looking at this, I can't really take anything out of each term, unfortunately. I kind of wish that was the case, but oh well. I'm thinking we could, oh, okay. I think I'll kind of ignore this example probably, just because the manner I would normally use it, I feel like that would be a little bit too time consuming. So let's try another one. How about this kind of gives us an opportunity to practice these kind of problems. So if you remember from an earlier factoring video, I talked about how do I work with like a t to the fourth, So I'm gonna first rewrite this as squares. So t to the t squared plus 20, and then t squared plus 100. So t squared is like what will be in the parentheses, right? Because they kind of act as an x. And then I'll still look at, okay, what two numbers add up to 20 that also multiply to 100. In this case, that's 10 for both. So t squared plus 10, t squared plus 10, and this is equal to t squared plus 10 squared. So that's my answer there. So now I want to go into difference of squares. And this, I think you should, well, maybe not memorize. No, okay, yeah, I think you should probably memorize this because this is really important to recognize. A squared minus b squared is equal to a plus b, a minus b. So for example, x squared minus 9 is the same thing as saying x squared minus 3 squared, which is equivalent to saying, which based on what I have up here for the difference of squares, this is the same thing as writing x plus 3 and x minus 3. So that's my answer here. And the reason why I think it's so important to know this is because looking at it, x squared minus 9, you can't take anything out of it. And I think it's difficult to conceptualize or just kind of looking at it like factoring it the normal way. So this is sort of a special type of like polynomial or binomial where we need to use this definition to help us do the factoring. Okay, so let's try x squared minus 4. So first I'm gonna again write these as squares. So I have just x squared minus 4 is the same thing as 2 squared. So I can write this as x plus 2 times x minus 2. And then let's try 9 minus 16t to the fourth, kind of just jumping straight into it. But it's the same idea. I'm writing this as squares. So 9 is the same thing as saying 3 squared minus, okay, so 16 can be written as 4 squared. Actually, let me just maybe write it piece by piece. So 16 is the same thing as 4 squared. T to the fourth is the same thing as saying t squared squared. So I'm going to kind of condense this a little bit and say minus 4t squared squared. You see, because when the squared is on the outside of these two, like it allows me to have the 4 and the t squared being squared. So we can see the equivalency from what we have here originally to here. And so now that I have them written in this form, I can go ahead and write the factored form of 3 plus 4t squared, and then 3 minus 4t squared, like that. So really the thing is you just write them as squares, and literally you'll just follow from this form. Okay, so I have m squared minus 4p squared. Again, keeping them as squares. So 4 I can write as 2 squared p squared, which is same thing as saying, okay, m squared minus 2p squared, right? Because both of them being squared, so I can just put the squared on top of both. And so now I can write this as m plus 2p times m minus 2p. Okay. Next thing is I could do 4t squared minus 64. This is the same thing as saying 2t squared minus 8 squared. So this is the same thing as saying 2t plus 8, 2t minus 8. All right, a squared minus 25b squared is the same thing as, okay, well, oops. It's a squared minus 5b squared. So then I have a plus 5b and then a minus 5b. So hopefully you can see the pattern of how I'm like writing both of these terms as like two things being squared. So yeah, that's the idea here. And I'll just do maybe one more and then end it. 64x to the fourth minus 25. Oh, sorry. Oops. Actually, I might have another one that I wanted to talk about, but oh, sorry, this was B25. Okay, wait. So I'm gonna write this as a square. So it's 8x squared squared, right? Because 8 squared is 64. X to the fourth, or x squared gives me x to the fourth, minus 5t cubed squared. That gives me 25, and also the t cubed squared gives me t to the 6. So it's the same thing as saying, oh, 8x squared plus 5t cubed, and then 8x squared minus 5t cubed. Okay, and now there's just, yeah, I think I'll just do one more of these. So if I had p to the fourth minus 16, this is the same thing as saying, oops, okay, no, I'll write it here. P squared squared minus 4 squared. So I can write this as p squared plus 4 and p squared minus 4. However, if you notice, I still have a difference of squares here. So I can still factor that out. So I am not done there. So I'm going to bring down the p squared plus 4. And we can agree that p squared minus 4 is the same thing as saying p squared minus 2 squared. So, so using difference of squares, that is the same thing as saying p plus 2 and then p minus 2. So this is my final answer for this problem. And okay, maybe I'll do one more of these. I'm sorry, I keep saying this is the last one, but I think just doing other examples is always helpful. So another one just like this. This is the same thing as 9x squared squared minus 1 squared. So it's the same thing as 9x squared plus 1, and then 9x squared minus 1. And again, I still have a difference of squares here. So the 9x squared plus 1 sticks around. But here I can write this as 3x squared minus 1 squared, which is the same thing as, so of course the 9x squared plus 1 sticks around. This is now 3x plus 1 and 3x minus 1. So this is my final answer for this problem.